Hello everyone, welcome back to the channel. Today we are tackling one of the most critical steps to writing a synthesizable hardware code in Verilog. Understanding the difference between a wire and a edge. If you have ever been confused why your code isn't working the way you expected it to work, this is likely why. Let us see the difference. A wire versus edge. A wire is generally used for as the name says, a physical electrical connection between hardware components. But a edge in general is used for something like a simulation rather than strictly what they become in physical hardware. Let us learn about the wire data type. Think of a wire exactly what it sounds like a typical physical electric connection between hardware components. It belongs to a group called net types. In this net types, we have various types that is WAND, which stands for wired and wired or and a tri. A wire generally cannot store value. It only shows us the output. It can only drive the output. And it always needs to be driven by using a continuous assignment. That means whatever the input it is coming, it will show it as the output. If you do not declare a data type for a variable or a port in Verilog, it's default to a wire of 1 bit width. Hardware. A wire always initializes into a physical wire or a piece of purely combination logic like an AND gate or an adder. The reg data type. Reg, which is in short for register. In simulation, a reg stores its value until a new one is assigned to it. The name reg does not mean it will always synthesize into a hardware register or a flip-flop. This is a bit false. While a reg can become a flip-flop, it can also become a standard combinational logic or a latch. We'll see it in the further slides on how it works. The key characteristics. As I said, a reg can hold on to a value and it can store value until a new value is assigned to it. It is always done using a procedural block such as an always initial or a function block. If used inside a clocked always block, it converts itself into a sequential logic, which is a flip-flop or something like that. If used in an unclocked always block, it behaves like a combinational logic. If used in an unclocked block, there are chances that it might convert into a latch. Latch is something that we all should be careful when we write a code. We're going to see how this latch can be avoided in the next slide. The golden rule. The left side of an assignment must always be an wire. Yeah, before I tell what is this is a blocking assignment and this is a non-blocking assignment. You will read about this in detail in the next lecture. And inside an always block, it must be a edge. And input ports must always be wire internally. See, it defaults to a wire of 1 bit. Then your model output port. It can be either wire or edge, depending on how you generate the output. Why I'm telling this is here you can see when I'm writing something inside a always block, it is your procedural assignment, I use reg. If I'm writing it outside a procedural assignment, I use wire. Let us use simple differences. They belong to the data type family of net and they belong to variable. Whereas a wire cannot hold a value, a reg can hold until new one is assigned to it. Assignment block. Wire is always outside a procedural block, reg is inside a procedural block. Combinational logic and physical connection. Here you have flip-flop latches or combinational logic. Initialization. This cannot be initialized upon declaration. Can be initialized and usually for simulation. See, wire can be used for input but not for an output. Here, output can be a wire as well as reg. You can see the example here. This is the example why we have used wire here. Since we are declaring it outside a procedural block, we have declared it using a wire. Here, this is acting like a simple, what you can call a sequential logic. Whenever there is a positive edge of the clock, the inputs are multiplied, that is using an AND gate, and the output is stored in out underscore R. Since it has a register, it can store a value. We are going to see a basic example of 2:1 multiplexer using a wire. You might be knowing the multiplexer works on a simple concept. Whenever the select line is a 0, it might show the first output, and whenever it is 1, the input is given back to the output. It means I1 will be the output. Let us see how it works. Here we are using two examples. One is using assign statement and another using always. The main thing you have to see is wire, and here it is a reg because this is a procedural block and this is a non-procedural block. That means you are using a continuous assignment here. If the select line is 0, you get output as A, and if it is 1, you will get it as B. This is simple working of 2:1 multiplexer. Here, what happens is if we are getting a always at start, means at any condition, at all types of condition. That means whenever your input is A, B, or the select line, this will change. Here, select line is 1 dash B1, and at that time you will get output as B, and in the else condition it will become A, that is your 0. Here, there is a very important concept about latching that we'll see in the next slide, and how reg is used for sequential logic. This is a simple D flip-flop with D as input, clock as an input, and output as Q. Here, we want to store the output value Q, and it is used inside a procedural block. Always at positive edge of the clock, you will begin. That means at every positive edge of the clock. See, the clock is positive here. So whatever was in D will go to Q, and whatever was in D here again goes to Q. Only when at positive edge of the clock. The value of D is captured and stored in Q. That is what it means to say. Now we'll learn about latch, what happens in latch. You have the same code which is similar to the 2:1 mux, but the thing is, in this we are not using the else statement. So what happens is the synthesizer must create a latch to hold on to the previous value of the output. Here we use the else condition. Let us see what it does. This is common bug for Verilog beginners. What when we write the code, no, we think that if we write the only the if part, it is enough. However, the compiler or the synthesizer will understand what is the else, and it will give the output automatically. But that is not the condition. The hardware works in a different type, so it creates a problem. What should be the output if the condition isn't met? Since Verilog dictates that a reg must hold its state until a new value is assigned, the synthesizer is forced to insert a latch. What if you do not use a else statement here and do not give a default condition? In the future videos, you will be seeing that if I'm using a procedural block like this and I have various conditions, at the end we'll mention a default statement. What this default statement will give is, regardless of whatever inputs you are giving and whatever your condition is, there will be a default value. I might set it to 000 or a 1 dash B naught, like that. This latch can cause several timing issues in modern FPGA and ASIC design. So thank you everyone. If you have any doubts, feel free to comment below. In the next video, we'll be discussing about blocking and non-blocking assignments. Thank you.